Okay, before you begin this, you should have a basic understanding on the differences between using data files and using text files and the advantages of using direct access versus sequential access. This video is not about that. This video is how do we look at direct access in action. We've been given a scenario. We've been given a hashing algorithm. We've been given a member ID for a sports club. At the moment, this is like a free list, you could say, with all member IDs being 0. If we were to enter in 1001 as a member ID, where would it put it in our structure? Well, member ID 1001 mod, which means we just care about the remainder, 100. So how many hundreds go into 1001? Well, we know that it's going to be 10, remainder 1. So 1001 will give us mod 1. Address will be 1. That's the remainder. So we find address 1, and we're going to put inside of this 1001. That would be where we put it. The next one, if we were to do it, 3005. Well, again, how many, if we did 3005 and we divide it by 100, we know that it will be a remainder of 5. So we find address 5, because that's the remainder, 5, and we put in 3005. The next one, 4096, well, we notice there's a pattern. You got 1, you got 5, we got 1, we got 5. So if it's 4096, the remainder will be 6. So, okay, so what we'll need is 100. We've got 4096, 100. How many hundreds go into 4,000? We know that that's going to give us 4, but then we've got a remainder of 96. That is our remainder. So we go to 96 and we put in 4096. The next one, 2098. We know then that will give us a remainder of 20. Well, also it'll give us a remainder of 98, so it goes into position 98. And the final one, 7002, remainder of 2, so 7002. There we go. That is us using this hashing algorithm, which was up here given to us, where we get a number, we mod it by a number, and whatever the remainder is where we place the member ID. Nice and simple so far. And then we've got this situation where we've been given some code. New member has its own record. So new member consists probably of a name, maybe, I'm making up these attributes, these fields here, address, I don't know, an age of a member, so all of that could belong to new member. But also, new member has a record called member ID, so each member will have a member ID, nice and easy. That is what we've been playing with here. These numbers are member IDs. So what we've got to do now is complete this pseudocode in order to do the following. Place our new member ID into the text file. In order for us to do this, we need to, first of all, get a member ID. Let's imagine it was 1001. And we need to perform the hash algorithm on it. So I'm going to call our hash function. And what we're going to put into it is our record called new member. But I need to hash the attribute member ID. So we're accessing just this field, member ID. If I just did this, it will try and hash all of our fields. But we just want member ID to be hashed, which is what we did at the beginning with this table. We hashed for member ID. So once we've got that, let's imagine it's given us the new address of 1. We want to move the pointer to the address for this record. In order to do this, we need to seek. So imagine this is our text file, or our data file, so to speak. We need to be able to, let's just erase all of this for a second. It needs to be able to recognize that new address is 1 based on our hash. So we need to seek and find number 1. So to do that, we just seek new address. So that will jump to position number 1. If it was the 40961 and we seeked new address, it would jump to 96. It then says put record membership file. So this is membership file, all of this. So we're going to put inside of membership file, in address number 1, our new details. So let's imagine that we've got Joe Smith, address 123 La La Land, age 42, member ID 1001. That's his member ID. We then hash the member ID. So the new address is 1 based on using this hash function. We're now going to put in Joe Smith, 123 La La Land, age 42, 1001 into this box here. So put record membership file, which is this file, and we're going to put in the record new member. So remember, this was called new member, and that is what we're putting in to membership file into position 1. How do we get to position 1? We seek the new address. So the pointer will point to here. So it knows we're putting it into here. And we're putting it into the member data part. The first question was basically saying to us, let's put into member ID the full member ID. So it'll look like this, 1001, and then it'll have in here like Joe Smith, age 42, blah, 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 123 La La Land. So if we were to do another one, whoops, daisy. If we were to do another one, and let's do the 4096. New member. Let's imagine we've got someone called Sally, 1 La La Land, age 90, membership ID, it was 4096. First thing we need to do is a hash algorithm, which is here to get the new address, which will give us 96. Inside 96, we're going to put then 4096. It then is going to seek this new address, which is 96. I'm going to put inside the following membership file, so it'll be Sally, 1 La La Land, age 90, 4096. The new member information. So the record, the whole record. If we did new member and then we did dot member ID, that would just put in 4096. If we did new member dot name, it'll just put in Sally. We're saying we want the whole record, all the fields, the name, the address, the age to be put into this place here. Okay, we've then got this next part, which is down below. So let's have a look at it. This is our old friend try and accept. In order for this to not crash if there is a wrong file name entered, we need to try open file. The name of our file will be membership file, so that's what we're looking for. And we're opening it up for random. If it doesn't exist, we need to output a message, and we want to output file does not exist. Just like that. That is what we want. Okay, a record with a new member ID 9001. So beforehand, originally we have inside our position 1, if you remember, 1001. We've got a person in there, Joe Smith, whatever, blah, 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 blah. Okay, so it's now saying to us, we've got a new person with 9001. If we perform the hashing algorithm, it will give us 1. Great, let's go and put it into 1. Uh-oh, there's something else already in there. That's not good. So this is called a collision, where we've already got information already in the member ID. What will happen is that 1001 will be overwritten by 9001, and it will be like Lucy. So the original data, so the OG data, will be overwritten. So that is the answer to this question. What is the problem? A collision. What actually occurs? The original data becomes overwritten. Nice and simple. So what we want to do is describe a method without changing the function hash, a way to handle a problem of a collision. So we know that we've got a collision. So if you've got 9001, we know that there'll be a collision. It'll have to go here, and it will change this and overwrite the data. So what can we do? Well, number one, what we could do is perform a linear search. So we know that this is going to be placed into position 1. But it's taken. So if it is taken, we're going to do a linear search until we find an available space where there's 0. In this case, the available space is in number 2, so we can just do 9001 here. And there we go. That is a solution. So we can store the overflow record, which is what this is, at the next available space in the sequence by doing a linear search. That is one option. So we can just go sequentially through it one by one until, I did not mean to do that. I hate it when my pen does that. Chillax, let's do it again. Until it finds a 0. When it finds a 0, shove it in there. That is one method. So there's another method, you might ask. Well, obviously, because I've just said that is one method. The other method is what we call an overflow area is created. What does that mean? Well, what we're going to do is we're going to, let's imagine we have 1001. We'll then create like a 2D array where we'll put 9001 in here as well. And then we'll have the data like Joe Smith, and then the next one was Lucy. So if we're searching for Lucy, and we want to get all of Lucy's information, we would search, it'll then find the address location, which would be 1. It'll then have to do another search inside of here. Is this Lucy? No, it's Joe, so it'll move on to the next person. Is this Lucy? Yes, it is Lucy, and we can then bring Lucy's information to our screen. So we create an overflow area which is created, which shares the same ID or key. We're going to call this a key. This is a key, this is a key, this is a key. So there are two different options. Create like a 2D array, so to speak. So it stores an overflow area where the home record is shared. So no longer are we just having Joe's record being there, we're also storing Lucy's. So it shares the same ID, the same key. Easy. So what we want to do is write some code to implement the method we described. So we're going to use the linear search version if there's a collision. So let's imagine we're entering in 9001. What we don't want it to do is overwrite this information. That will be bad. That will be terrible. We do not want that. In order for us to do this, we need to use, first of all, a command called get record. So we're going to be using pseudocode for this. The name of our file, membership file. And what we're going to do is we're going to put that into a variable called current record. So if current record starts on 0, that's where the information will be. While our current record dot member ID is not equal to 0. So when it doesn't match 0, we're going to be looping all the way through this until we find an available spot. New address equals new address plus 1. If new address is greater than 99, then new address becomes 0. So what's going on? We'll talk about the loop in a second, but we've made a variable called new address. We've got 99 different possible addresses. We could be starting from here. Let's imagine what we're putting in 7096. And let's imagine that we're looking for an available space. There's no space here. So let's check here. But let's imagine we've got something in here. So there's something there. We want to then loop back to 0 again and check what's in here. Then check what's in here, then check what's in here. So we're saying if new address is more than 99, then let's make sure it's circular. Let's go back to the beginning again. We're then going to seek new address. So seek new address means we're going to jump to that location. We're then going to get record membership file current record. So what is going on? I'm going to just do cur for current record. Cur means current record, and then I'm going to do end while. Let's zoom out slightly. Let's move the end while down here. And let's just put current record in here. Okay. Let's say we've got 7002, 03, 04, and this is 0, and then we've got 6 in here, and 7 in here, and 8. I'm just writing in numbers here. And let's do 96 in here, 97, 98. Okay, cool. Get record, membership file, current record. So let's imagine that we're entering in, I don't know, 7001. Whilst current record, member ID is not 0, so let's go to 7001, which gives us here, if we use a hashing algorithm, there's something in here, it's not 0. New address will go up by 1. If new address is greater than 99, well, it's not. So what we do is we're going to seek and then now go to position 2. We're going to get what's inside of here. Is it 0? No, it's not. So it's going to loop again. New address is going to become 3. We're going to seek, which means go to that location. What's inside? Number 3. But so it's not 0. So it's going to loop again. So it's going to go up by 1 again. So we're now going to go to 4. If new address is greater than 99, no, it's not. Is it empty? No, it's not. It's got a 4 in it. So new address goes up by 1 again. We're then going to seek. What's inside? It's 0 is inside. So when we loop, current record is 0, the member ID, so we're going to stop the loop. We found a place to put in 7001. Cool enough. So let's imagine that we want to now put in place let's just put something in here, 7099. We want to put in place 1098. If we mod that, it'll give us 98. If we run this code, it will jump to 98. It'll go inside of it. It will see that there's something there already. It might be 1298. Actually, that won't work. Let's say 4098. Uh-oh, something's in there. Because it's in there, we're going to make address go up by 1. So now we're going here. So we seeked this new address. So we've done seek. We've gone inside of it, and there's something in there as well. When we loop again, if new address is greater than 99, so it will be, if we've gone up by 1 by doing this, we were 99 before, we're now on 100, new address will basically get turned back to 0 again. It'll then check inside there. Is that a 0? Yes, it is a 0. So this is where we can put our 1098. Using a linear search to handle the collision, the overflow. So, get record is get the current record information. The loop will loop through whilst the member ID, which is here, is not 0. When it is 0, we found our location. New address will keep going up by 1 each time, but then we have to seek, which takes us to the address. We then check to see the member ID inside. If it's 0, we stop. If it's not 0, we loop again. The get record is retrieving the member ID from each one. That's what the get record is doing. Let me just move this so you can see. That is what this line of code is doing. It gets a current record and it checks the member ID when we loop around. So the current record is going to have all the information in that current slot. So all the information in the data. When we loop, we're just checking the member ID to see if that's 0 or not.